Hello my dear class 10 students. I welcome you to NEET World. So in this session we will be continuing our discussion on acids, bases and salts. Okay. So particularly we will be discussing about what exactly ionic product of water means. Okay. So in the last class we discussed about pH and pH calculations, and when we mix two acids or two bases, how can we calculate resultant concentration of that acid or basic mixture, and how can we express pH for those solutions. These things we have discussed. Now we will be discussing about ionic product of water, which is very useful. Okay, so let us start our session. See, before going to the session, I just wanted to show you one more thing. If you are really looking for a best mentor to discuss your doubts and any other concerns regarding your preparation, so can feel free to ask us in this Telegram channel. So you just scan this, so it will direct you to the Telegram group of this NEET World YouTube channel. Okay, so that is run by our team, so they can guide you and we will be also there. So they will give you the questions and also they will update you regarding the class timings or what are the sessions which we are going to conduct in future. So that like that you will get daily like timetable, I can say, daily schedules you can say. Okay, so everything will be updated in this channel, so you can freely join in this and you can get updates from us. Okay, so let us start our session. Here we will be discussing about ionic product of water, right? So what exactly ionic product of water? We know water undergoes self ionization and forms H plus and OH minus ions. So water is a weak electrolyte, it will go self ionization to form H plus and OH minus ions. Okay, now when one molecule of water is undergoing dissociation, we are getting one H plus ion and one OH minus ion. Number of H plus, number of OH minus ions are equal in amount. Therefore, overall molecule will be neutral only. Okay, even it is undergoing dissociation, the number of H plus and OH minus molecules liberated from one molecule of water is equal. Therefore, overall solution will be neutral. Hope it is clear. Now, if we consider the equilibrium, see this is the equilibrium symbol, see forward, backward. It means it is a reversible reaction. So I can say this is a weak electrolyte. Now the ionic product of water, it means what? See, we know for this equilibrium we have equilibrium constant. So this equilibrium constant is written as concentration of products H plus into concentration of reactant, square bracket represents concentration, like this, by concentration of water. Since water is a pure substance here, the activity or the concentration of that pure substance is considered to be 1. It means, so K into concentration of water, here I am writing just for understanding purpose. So I am writing here H plus into OH minus ion. Okay, so overall this value I am taking it as KW. KW means what? Ionic product of water. What is that? Ionic product of water will be equals to how much? Concentration of H plus into concentration of OH minus ions. That's it. Okay, so what we can call this KW? KW means ionic product of water. It is nothing but concentration of H plus into concentration of OH minus. These are the ions liberated from this acid water. Therefore, the ionic product of water is taken like this. Hope it is clear. Now, the concentration of H plus and concentration of OH minus ion at 25 degrees Celsius. At 25 degrees Celsius I am saying. So concentration of H plus and concentration of OH minus ions are found to be 10 power minus 7 molar. This is the concentration of both ions at 25 degrees Celsius. Okay, it is equal, concentration is equal. So now what happens to ionic product value? KW equals to H plus ion concentration is 10 power minus 7 molar. Similarly, OH minus also 10 power minus 7 molar. So I can write 10 power minus 14 is the value of KW at 25 degrees Celsius. Hope it is clear up to here. Now what if I change the temperature? Now I am writing at 90 degrees Celsius. At 90 degrees Celsius, the concentration of H plus and concentration of OH minus ion is found to be 10 power minus 6 molar. 10 power minus 6 molar. So in this case, what happens to Kw value? So Kw value becomes 10 power minus 6 into 10 power minus 6. That will be 10 power minus 2 molar square, I can say. This is at 90 degrees Celsius. So what you are understanding from this? So this dissociation of water or ionization of water is favored by increase in temperature. So whenever we increase the temperature, the water molecules are getting dissociated or getting ionized easily. So it means this forward reaction, this forward product ions formation is taking place more readily when we increase the temperature. So the process which is favored by rise in temperature, by increase in temperature, are called endothermic process. What is that? Endothermic process. So dissociation of water is endothermic process. Hope it is clear now? Yes. If it is clear, just click on the like button once. Yes. Now here, when we have discussed in the previous class, like pH plus POH equals to 14 I have given now. Yes. Why I have given that? I will show you now. Look here, Kw means concentration of H plus into OH minus ion I have taken now. So its value is now how much? At 25 degrees Celsius. Now we will discuss everything at 25 degrees Celsius. It is equals to how much? 10 power minus 14 I can say. Now I am taking it once again. Kw equals to concentration of H plus and concentration of OH minus equals to 10 power minus 14, right? I have taken that value over here. Now apply log onto this equation, complete equation. So log Kw will get, which is equals to log A into log AB we have. So we can write log A plus log B, right? So log of concentration of H plus ion plus log of concentration of OH minus ion equals to log of 10 power minus 14. I am writing like this. I hope it is clear, there is no confusion, right? Now apply negative sign on all the sides. So here, there, you can apply. So minus log Kw equals to minus log concentration of H plus minus log concentration of OH minus equals to minus log concentration of 10 power minus 14. Just write like this. Okay. So we know minus log concentration of H plus is nothing but pH. What is this? This is the indication of pH, right? Minus log concentration of H plus is nothing but pH. Similarly, in the place of H plus, we have OH minus now, so we can say it as POH. Hope it is clear. Similarly, if you look here, in the place of H plus, we have something called Kw. So you just write it as PKW. Hope it is clear. Now, if you look here, minus log 10 power minus 4. So if we have something like this, log A power B if we have, so we can write it as B log A, right? B log A we can write. So it means here minus 14 into minus, it will become what? Plus 14, log 10 means 1. So overall value will be 14. Hope it is clear, and this discussion is at what temperature? At 25 degrees Celsius. Okay. If we do this discussion at 90 degrees, that will be equals to how much? That will be equals to something around 12, right? That is at 90 degrees. Hope it is also clear. Now let us take here. See, that's the reason in the last class we have written pH plus POH equals to 14. Okay. So this is the relation you can use. pKw equals to pH plus POH, sum will be equals to 14. So at this condition, I can say on the pH scale we have from 0 to 14, right? So the midpoint here, the center point here, that is 7, is considered to be neutral. This is on pH scale I am discussing. Okay, neutral, and below this 7 considered as acidic, and above this 7 considered as basic region, right? So as we move towards 0, acidic nature increases, right? As we move towards as we move towards 14, the strong basic nature we have, right? So 14 means stronger basic, 7 near to 7 means weaker basic, okay, low basic region. That is what we can understood from this. Now what if I want to discuss this at 90 degrees? pH plus pOH equals to 12. So in this case pH scale should be taken from 0 to what value? 14 not, this is 14 at 25, this is at 90 degrees, you should take at 90 degrees, you should take it is up to 12, okay. So here the midpoint here I should consider is 6. So below 6 is acidic, above 6 is neutral. Hope it is clear. Now if there is a statement given like this, the 7 is a neutral point on pH scale. Is it true all the case? No, it is not true. pH is a temperature dependent. As temperature changes, pH values also changes. It means 7 at 25 degrees on pH scale is considered to be neutral, but at 90 degrees when we say 7, that becomes basic region, because here 6 is a neutral point at 90 degrees. Hope it is clear. So what is the only factor that is affecting pH value here? That is temperature. So that we can make a statement that pH is a temperature dependent. Hope it is clear, right? So these are the important things that you have to be remember, okay. So now I wanted to give you one more equation here, and I wanted to make you little more clear on this topic. See, we know we have weak acids and weak bases, right? So let us say I have a weak acid, HA is a weak acid. Now it will dissociate like H plus and OH minus, A minus. Let us say acetic acid, acetate ion we will get as anion and H plus ion as a cation. That is what acid nature of that acetic acid. So now this dissociation constant Ka can be taken as concentration of H plus ion into concentration of A minus ion. By this pure substance, so its activity will be 1. So this will be the final equation we will get, acid dissociation constant. So from this what you can understand, as Ka value increases, see, if more greater the Ka value, greater is the value of H plus. It means stronger the acidic nature it will be, greater is its Ka value. So I can write Ka value directly proportional to concentration of H plus. This is directly indication of what? Its acidity. So greater is its acidity or greater is its acidic nature, more Ka value or greater is its H plus ion concentration. Hope it is clear. Now let us discuss few more things. Okay. So similarly for bases what will be having? Kb. So Kb will be equals to what? So Kb will be equals to concentration of OH minus ion into some concentration of cation. So from that what can we get now? Kb will be directly proportional to concentration of OH minus ion. That is nothing but it is directly proportional to its basic nature. More is its basic nature, greater will be its Kb value, and concentration of OH minus value also very high here. Hope these relations are also like understood clearly, right? Now I will be giving you one more thing. So Kw when we have written, you have told it as pKw by applying log, minus log on both sides. Whenever we have told you H plus ion concentration, then we have written pH. So while writing pH, what you have made it? So you have made it as minus log concentration of H plus, right? So Kw means minus log concentration of or value of Kw you have taken. So here I am writing Ka. So what you have to make here? So pKa you have to write. So pKa will be how much? Minus log concentration of or value of Ka. That's it now? Yes. So from this we can make one relation. See, more the value of H plus ion, lower is its pH. More acidic a substance, lower is its pH value. So higher H plus ion value, lower pH. So concentration of H plus ion means more acidic it is, so its pH value will be less. Hope it is clear. Now based on this greater Ka value, lower will be the pKa. So I just want to include this pKa relation into this. So can I make this as inversely proportional to pKa? Yes, we can make, because see, minus of Ka, minus log of Ka, how they related? So we have a negative sign that makes it more Ka value, lower pKa value. Hope it is clear. So this is the relation in the case of acids you can use. Okay. Similarly in the case of bases, so what we can say, Kb directly proportional to concentration of OH minus ion. Okay. So here I just used these proportionality symbols to make you relate Kb value to the OH minus and to the base signature. Okay, that's it. Now this will be what? Inversely proportional to pKb. Similar to pKa, we will be also having pKb. Okay, so this is one more relation you need to remember. Okay, so based on this, now I will be telling you two acids, two weak acids, like acid 1 is HCA1 I am saying, acid 2 HCA2 I am giving you. So now it is having pKa value, pKa of acid 1, so pKa of HCA1 is greater than pKa of HCA2. Now tell me, based on this question, which is stronger acid it is, which is having more acidic nature out of these two, HCA and HCA1 and HCA2, which is having more acidic nature? Tell me, based on this understanding. See, more pKa, lower acidic nature. So pKa value is more for HCA1, therefore it is lower acidic than or less acidic than HCA2. So acidic nature is acidic nature of HCA2, acid 2, HCA2 is greater than HCA1. So this is how you can understand the concept of pKa, pKb's, Ka, Kb, like this. Hope it is clear. And one more question I am giving. So Ka value of acid HCA1 is greater than Ka2. If I say like this, so what it is mean? So this is about the first question. I am making one more second question here. So Ka1 is lower than Ka2. So what do you mean by this? So greater the acid dissociation constant. So out of this, this is for first acid, this is for second acid. Okay. So this is for first acid, this is for first acid, this is for second acid. Now tell me, which is stronger acid? So acidity directly proportional to Ka value, right? So Ka2 has greater value, therefore it is more acidic. So you can say HCA2 is stronger acid than HCA1. Like this you can understood this topic. I hope everything is clear. Now look at this. Look at this, what I told you, a 25 degree solution, neutral solution, it is having this much concentration of H plus and OH minus. So what is the pH condition summary we can get? So from here we can get, acid solution means concentration of H plus will be greater than concentration of OH minus. So this is nothing but, if you apply here, concentration of H plus ion concentration will be definitely greater than the 10 power minus 7, then that solution is considered to be acidic. Similarly, for basic, OH minus ion concentration will be greater than 10 power minus 7. Hope everything is clear. Now remaining things, that is importance of pH in our daily life. We will be seeing this in the upcoming session. I hope everything is clear and stay connected with us for the next session. Thank you for watching.